Hi everyone, I am Rosa Mikalo and I will be presenting the continuation of the respiratory system, which is the lungs. So lungs is the major organs of the respiratory system and is responsible for the gas exchange. So the lungs occupy most of the thoracic cavity and heart and the lungs work together for gas exchange. The heart occupies a central portion called the mediastinum. In the lungs, we can see the apex, which is near the clavicle, the base that rests on the diaphragm, and each lung is divided into left lobes by fissures. So the left lung has two lobes. The right lung has three lobes. So this is illustration, an anterior view of our lungs. We can see here the apex of the lung, this one, the right superior lobe, the horizontal fissures, the right oblique lobe, the oblique fissures, the right inferior lobe, the heart, which is in the pericardial cavity of the mediastinum, the diaphragm, the base of the lung, the left superior lobe, the oblique fissures, and the left inferior lobe. So we can see here the difference, the body. Um, this one has three lobes, and the left has only two lobes. So this is a first section of our lungs, which is viewed from above. The lungs pleural membranes and the major organs can be seen, and also the mediastinum. We can see in the mediastinum we have the heart. There's veins, mga vertebra, posterior esophagus, and etc. So the lungs is covered with a covering called a serous membrane. So the serasa covers the outer surface of the lung called the pulmonary or the visceral pleura, and the parietal pleura that lines the walls of the thoracic cavity. So the pleural fluid fills the area between the layers of pleura to allow gliding. So this happens when we breathe. The pleural fluid fills the area para nga dili magasgas ang atuang, dili ta malisod o ginhawa, which allows the gliding of the lungs with its surfaces. And these two pleural layers resist from being pulled apart. uh, the bronchial tree division. It is all about the smallest of these passageways have a reinforcing cartilage in their walls. The the primary bronchi, the secondary bronchi, the tertiary bronchi, the bronchioles or the smallest conducting passageways, the terminal bronchioles. So this is an illustration of the bronchial tree division. We can see here the alveolar duct, the alveoli, the alveolar sac, this one inside the circle, and terminal bronchiole. Inside the alveolar sac, you can see the alveolar pores and alveolar duct and also the alveolus. So this one is responsible for the respiratory zone. That includes the, like what I said earlier, the bronchioles, the alveolar ducts, the alveolar sacs, the alveoli, which is the only site of gas exchange, which is in the alveoli only. And respiratory membrane, it is responsible for the gas exchange. It has two components, which is the alveoli or the alveolar membrane and the capillary membrane. So together, these two, the alveolar and the capillary walls, they fuse basement membranes and occasional elastic fibers, construct the respiratory membrane, which has gas flowing past on one side of the blood, flowing past on the other. So in respiratory membranes, we have a chunky alveolar walls, which is the cuboidal cells. So this cuboidal cells, it produce lipid or fat molecules called the surfactant. This surfactant coats the gas exposed alveolar surfaces and is very important in lung function, which are sometimes called dust cells. These dust cells wander in and out of the alveoli, picking up bacteria, carbon particles, and other debris. So the physiology of the respiratory system. So the major function of the respiratory system is to supply the blood with oxygen and to dispose carbon dioxide. So to do this, at least four distinct events collectively called the respiration must occur. So in respiration, we have a pulmonary ventilation in which air moves in into and out of the lungs so that the gases in the air sacs are continually refreshed. And this process is called breathing. The external respiration happens when gas exchange between the pulmonary blood and the alveoli must take place. The respiratory gas transport is happening, which oxygen and carbon dioxide must be transported to and from the lungs and tissue cells of the body by the bloodstream. Internal respiration, so at the systemic capillaries, gas exchange must be made between the blood and the tissue cells. So the mechanics of breathing in pulmonary ventilation, we have two phases: the inspiration or inhalation, and the expiration or the exhalation. So the pulmonary the mechanics of breathing has rules. So this rule means that the volume changes lead to the pressure changes, which lead to the flow of gases to equalize the pressure. In inspiration or inhalation, the air is flowing into the lungs. Chest is expanded laterally, the rib cage is elevated, and the diaphragm is depressed and flattened. Lungs are stretched to the larger thoracic volume, causing the intrapulmonary pressure to fall and air to flow into the lungs. The expiration. So expiration is when the air is leaving the lungs. So the chest is depressed and the lateral dimension is reduced. The rib cage is extended and the diaphragm is elevated and dome-shaped. Lungs recoil to the smaller volume, intrapulmonary pressure rises, and the air flows out of the lung. The intrapulmonary volume is the volume is in the lungs. The intrapleural pressure is the pressure of the pleural cavity. Sorry. So non-respiratory air movements are the result of reflex activity, but some may be produced voluntarily, such as cough, sneeze, crying, laughing, hiccups, and yawn. So respiratory volumes and capacity. So in respiratory volumes, we have a tidal volume. So normal quiet breathing moves approximately between 500 ml of air into and out of the lungs with each breathe. So in respiratory reserve volume, the amount of air that can be taken in forcibly over the tidal volume is the respiratory reserve volume, which is normally between 2,100 ml to 3,200 ml. So respiratory reserve volume is the amount of air that can be forcibly exhaled after the tidal expiration. So the respiratory reserve volume is approximately 1,200 ml. The residual volume, even after most of the string's expiration, about 1,200 ml of air. So this is called the residual volume or the residue. And it is important because it allows gas exchange to go on continuously, even between breath, and helps to keep alveoli inflated. The vital capacity is the amount of exchangeable air is typically around 4,800 ml in healthy young men. And this respiratory capacity is the vital capacity, which is the sum of the tidal volume, inspiratory reserve volume, and expiratory reserve volume. And the dead space volume from its word dead. So it is um the space much of air enters the respiratory tract, remains in the conducting zone passageways, and never reaches the alveoli. Since it never reaches the alveoli, uh, it is a dead space volume. So it amounts about 150 ml. The functional volume, in which the air that actually reaches the respiratory zone and contributes to gas exchange, about 315 ml. The spirometer, so respiratory capacities are measured with a spirometer, wherein as a person breathes, the normal volume of air exhaled can be read on an indicator, which shown the changes of air volume inside the apparatus. So next one is the respiratory sounds. So the bronchial sounds are produced by the air rushing to the large respiratory passageway or from the trachea and bronchi. So the vesicular breathing sounds uh, are the sounds whereas air fills the alveoli and the air soft and resemble a muffled breeze. For the external respiration, gas transport, and internal respiration, external respiration, it involves oxygen being loaded and carbon dioxide being unloaded from the blood. Internal respiration is in which oxygen is unloaded and carbon dioxide is loaded into the blood. So gas transport, so oxygen is transported into the blood in two ways. Most attaches the hemoglobin molecules inside the RBCs to form oxyhemoglobin, or the very small amount of oxygen is carried to dissolve in plasma, while carbon dioxide is transported in plasma as bicarbonate ion, or a smaller amount is carried inside the RBCs bound to hemoglobin. For the control respiration, we have a neural regulation. In neural regulation, we have a phrenic and intercostal nerves. So these two nerves regulate the activity of the respiratory muscles, the diaphragm and the external intercostal. Next is the medulla and pons. Pons centers appear to smooth out the basic rhythm of inspiration or inhalation and expiration or the exhalation set by the medulla. Euthymia, the normal respiration rate is referred to as euthymia, and it is maintained at a rate of 12 to 15 respiration per minute. Hypernia, this hypernia is usually happens during vigorous exercise wherein the brain center send more impulses to the respiratory muscles and the respiratory pattern is called hypernia. Um, for the non-neural factors influencing the respiratory rate and depth is the physical factors, which mean that although the medulla respiration center set the basic rhythm of breathing, there is no question that the physical factors such as talking, coughing, and exercising can modify both the rate and depth of breathing, as as well as increased body temperature, which increases the rate of breathing. Second is the volition or the conscious control, which means that voluntary control of breathing is limited. And the respiratory centers will simply ignore messages from the cortex when the oxygen supply in the blood is getting low or blood pH is falling. So the emotional factor can modify the rate and depth of the breathing through reflexes initiated by the emotional stimuli acting through centers in the hypothalamus. So when you're emotionally um when you're attached to the feeling emotionally, dili malusot ka ginhawa. This is because too much the emotional stimuli acted to the center of the hypothalamus. The fourth one is the chemical factor, which is the most important factor. That means that the levels of the carbon dioxide and oxygen in the blood, increased levels of carbon dioxide and decreased blood pH are the most important stimuli leading to an increase of rate and depth of breathing, while a decrease in oxygen levels become important stimuli when the levels are dangerously low. That's why bitaw nga, if mangitso ng ginhawa ang tao, it's ginabutangan siya of oxygen. Pinapa-oxygen siya para mag-normal ang iyahang breathing. So the hyperventilation blows off more carbon dioxide and decreases the amount of carbonic acid, which returns blood pH to normal range when carbon dioxide or other sources of acid begin to accumulate in the blood. And hypoventilation, the last one, or the extremely slow or shallow breathing allows carbon dioxide to accumulate in the blood and brings blood pH back into normal range when blood starts to become slightly alkaline. So that's all for my report for today. I am Rosamine Calo, so thank you very much for listening.